Okay, so this is part 284C3M1b7C8E13C9C6D3E. Line 22f1fa19c3m1b7C8E13C9C6D3E. Histidine Imidazoles Paramagnetism Formula 5G Wow Seti. There's the alien radio signal. This particular lens is about the UFO paramagnetic forces formula for levitation and airsickness cures. Alien technology from a wild data. The next Kubrick state is going to be Googled in the next video. That's the next keyword we'll be looking at. January 14th, 2013. Today's the 16th. Keyword from the previous videos is line 22f1fa19c3m1b7c8e13c9c6d3e. Divalent Binuclear copper crystal reference formulas 5G Wow Seti. So there's a lot of cross-referencing in that video, and basically there was all these keywords that came up for it, so I just did 10 other videos with each of the keywords, okay? Because I didn't know what they meant. The previous video is from line 22f1fa19c3m1b7c8e13c9c6d3e. Copper Dinuclear Toroid Blade UFO 5G Wow Seti. There is another formula in there which I just noticed, and I'll be doing it about 10 videos after this one. Oops. You know what I did? I goofed. There. Previous video title. There. That's better. Okay. So, you can tell I'm in a hurry, right? Because when I'm in a hurry, I make mistakes. Too many of them. So this is a keyword. Histidine Imidazoles. So histidine is abbreviated as HIS or H, is an A amino acid with an imidazole functional group. It is one of the 22 proteinogenic amino acids. Its codons are CAU and CIC. Biochemistry. The imidazole side chain of histidine is a common coordinating ligand. So we have the keyword of ligand coming up again. And metal O proteins. A D, and that's another keyword as well that's come up with the bendable metal ideas. And D is a part of catalytic sites in certain enzymes. So this is talking about the enzymes that we need. In catalytic triads, the basic nitrogen of histidine is used to abstract a proton from serine, threonine, or cysteine to activate it as a nucleophile. In a histidine proton shuttle, histidine is used to quickly shuttle protons. It can do this by abstracting a proton with its basic nitrogen to make a positively charged intermediate and use another molecule, a buffer, to extract the proton from its acidic nitrogen. In carbonic anhydrases, a histidine proton shuttle is utilized to rapidly shuttle protons away from a zinc-bound water molecule to quickly regenerate the active form of the enzyme. So the keyword here is regenerate, right? Histidine is also important in hemoglobin. In helices E and F, histidine assists in stabilizing oxyhemoglobin and establishing CO-bound hemoglobin. As a result, carbon monoxide binding is only 200 times stronger in hemoglobin compared to 20,000 times stronger in free heme. So it's talking about binding and strength, right? And also of enzymes and water molecules. So the keyword paramagnetism is a form of magnetism whereby the paramagnetic material is only extracted when in the presence of an externally applied magnetic field. So that would be our Higgs electronic field, right? In contrast with this behavior, diamagnetic materials are repelled by magnetic fields. So there we can use that for antimatter. Paramagnetic materials have a relative magnetic permeability greater or equal to unity, positive magnetic susceptibility, and hence are attracted to magnetic fields. So that would create our magnetic field if we wanted to use that in the space elevator equation. The magnetic moment induced by the applied field is linear. So there's another keyword there, linear. And the field strength and rather weak. So weak would be our weak bosons. It is typically requires a sensitive analytical balance to detect the effect, and modern measurements on paramagnetic materials are often conducted with a squid magnetometer. So here's a trickle of liquid oxygen. It's deflected by a magnetic field and illustrating its paramagnetic property. I don't know if you can see it there. It's very faint. Unlike ferromagnets, paramagnets do not retain any magnetization in the absence of an externally applied magnetic field, because thermal motion randomizes the spin orientations. There's the keyword spin and thermal motion. Some paramagnetic materials retain spin disorder at absolute zero, meaning they are paramagnetic in the ground state. Thus, the total magnetization drops to zero when the applied field is removed. Even in the presence of the field, there is only a small induced magnetization because only a small fraction of the spins will be oriented by the field. This fraction is proportional to the field strength, and this explains the linear dependency. The attraction experienced by ferromagnetic materials is nonlinear and much stronger, so that it is easily observed, for instance, by the attraction between a refrigerator magnet and the iron of the refrigerator itself. Okay, my thoughts. Retain the spin at absolute zero. The symbol for zero, the main number, is 5.8783279E6, square root of 0. Add your paramagnetic ground state. Magnetization will drop to 0. Antimatter, weightlessness, airsickness problem, and air travel. Spin, Higgs field fraction, field strength, linear dependency. Attraction, ferromagnetic materials, nonlinear, stronger attraction between magnetic forces, iron alloys. So next is we're going to Google is cupric state. I wonder if I did linear dependency or not. Probably did. Okay, so thanks for watching.